Hi guys, today we'll do the 2026 problem 6 from the AIME 1. So, the product of all positive real numbers x satisfying this equation is an integer p. Find the number of positive integer divisors of the integer. So, before I get into this, I'm just going to try to simplify this equation. Let's set, motivated by this log base 2026 of x, to get rid of this sort of weird term in the exponent, let's set x to be some 2026 to the a. So this lets us simplify our equation as 20 through of 2026 to the a equals 26 times 2026 to the a. And now let's just go through and simplify these. So 2026 to the a squared is going to equal 26 to the 20th times 2026 to the 20a. Then we get 2026 to the a squared divided by 2026 to the 20a is equal to 26 to the 20th. Then let's simplify this left-hand side. 2026 to the a squared minus 20a equals 26 to the 20th. And so we want to solve for a because we want to find all the values of x, and each value of x is uniquely determined by the value of a here. So solving for a, we can see it looks sort of quadratic, and to make it fully quadratic, let's take the log, so we're only dealing with a's and not these powers. So now we get a squared minus 20a equals the log base 2026 of 26 to the 20th. And bringing this over and simplifying this side, a squared minus 20a minus 20 log base 2026 of 26 equals 0. And now we finally have a quadratic. So we can see that there's only two positive real numbers that satisfy this equation since we have a quadratic here. And we want to find the product of these numbers x. So let's say since we know there's two numbers, we can write the first one x sub 1 and the second one x sub 2. And we'll just define these to be 2026 to the a sub 1, and then define this one to be 2026 to the a sub 2. And if you want to find x1 times x2, which is the product, we get 2026 to the a sub 1 plus a sub 2. That's really key here. We basically just have to find the sum of the values of a that satisfy this equation here. So instead of having to deal with this weird term, which is you would think by Vietas that this contains a product, we only actually have to deal with this one since it's the sum. So now we know that a sub 1 plus a sub 2 is equal to 20 by, again, Vietas. So our x1 times x2, or we know that's p, I think that's the integer they gave, yeah, p is equal to 2026 to the 20th. And let's just decompose this. This is equal to 2 to the 20th times 1013 to the 20th, and 1013 is prime, so we can actually stop right here. We want to find the number of positive integer divisors of this number, and the formula for that is this exponent plus 1 times this exponent plus 1, since just 21 times 21, so it's 441, which is our answer. The reason we multiply the exponents is because you can either have the 0th exponent of this, or you could have the first one, second one, you can choose any number. So since we're including 0, there's 21, and similarly here, you could have 1013 to the 0th, you could have 1013 to the first, second, third, all the way up to 20. So again, there's 21 different options you can choose, and once you combine those, you would have constructed every single possible integer divisor. And so that's how you count it. And we get our answer 441.